So to do the two windows like you're doing, Ron, did you open two instances of the meetup thing?
Oh, what I have is I'm presenting I have two screens right now up on my computer, and I'm presenting the screen that has the graphics on it. So I'm just sliding my browser window over there at will. So ordinarily I'll keep that out of the way unless I'm talking or whatever.
Yeah. Do a Ron pop-up. Pop over.
Hey, can everyone hear me?
Yeah, you're good.
Okay, sorry, this is a little confusing here. I'm going to just do one thing and then, well, anyhow, I'll fix this.
Hello, Carl.
Echo should be good. All right, let's get started. So welcome everyone to the 12th of September. We are today going to go through two presentations in DPRG's monthly meeting. First, Ron Grant will give an update on his landfalling simulator. And Ron, what do you think? Is it an hour, 45 minutes? Like
no, I hope a lot less than that.
A lot less, okay. And then after that, I will attempt to give a demonstration of Open Broadcaster software, Open Broadcaster Studio, and then some other wild tools you can connect with it. So with that start, I'm going to stop gabbering and let Ron take it away.
Okay. Here is an update on the line following simulator. I've been working on the simulator and been working on a client server model. Hey, I'm picking up, I can probably handle it, but I seem to be picking up sound coming from something. Maybe it's me. I'll tell you what, I'll turn my speakers down a bit. Okay, that'll get rid of my, whatever, that'll help me. Okay. So here is the latest rendition of the line following simulator, and the one thing that I've changed in the simulator that was previously not existent was I added acceleration rates to the simulator. Previously, you could set a turn rate or velocity instantaneously attain that rate. And I thought if we were going to use this in a contest setting, that the simulated robot probably needs to behave a little more realistically. And so what I have, and I'll kind of talk about just the constants, and these are defined by the server, the simulation server, which is now given the responsibility of updating the robot position. You will hand the robot server just as before a speed and a turn rate, but really technically those rates are target speed and target turn rate. And the idea is that if you decide you want to go 6 inches per second, or we'll say 10 inches per second, then you're going to be subject to the simulator's maximum acceleration rate. Now, you can set your own acceleration rate to any value less than what the simulator publishes as a maximum. So, for example, if I say my robot is kind of sluggish and I want to allow it only, let's say, 10 inches per second acceleration, that means to obtain full velocity, it'll take 1 second to reach 10 inches per second. So the idea is that this prevents a simulated robot from jumping around on the course, things that we don't typically see. There might be some argument against the simulation becoming restrictive. But anyway, so just to kind of go through a few of there's a maximum acceleration and a separate deceleration rate. Typically, I imagine those are identical. And then there's a turn acceleration rate, and that is in degrees per second per second. And so there, the idea would be, in this case, you could obtain a 360 degree per second rate in about a half a second. So fairly nimble robot. The maximum speed, another value that you may want to arbitrarily set well below this at 36, you'll probably break the simulator as far as based on the time step. That is another fixed value. And in fact, this value is fixed by the simulation. That way all competitors will have the same time step in their robot that they're attempting to build a controller for. I chose around 60th of a second. Actually, that's about, I believe, 166. I think anyway, it's close to a 60th, slightly different than that as far as the simulation time step.
Hey, Ron,
okay, so
Ron,
with those values in mind, whether you have to worry about it or not is just a question of just how much you're pushing your robot. And let's run the example, and then we'll kind of look at what's going on. Okay, so I'll get this out of the way. And the idea also, by the way, and I'll do just a brief display of the updated robot dynamics. And those now, in fact, I'll do that now. Let's just do that now and get it out of the way. So as far as when you set a rate, we'll just use speed for an example. Technically, what's getting set is the target speed. So if my current speed is 0 and we set our target to 10, you'll see in the simulation loop kind of what happens. I'm going to scroll down. Bear with me a second here. We get to the drive update. Okay. So here, if our speed is less than our target speed, the simulation will accelerate the robot by a rate that we stated, and I'll have to give some examples of this in the future to make it maybe more clear. But the idea is that your robot will ramp up to the target speed, and if for some reason if we slightly exceed it, we have a statement here that clips or clamps the speed to the target speed. So if we say we want to go 10 inches per second, it's going to take typically a few time steps to reach that speed, just as it would in real life. So anyway, we'll talk more about that, and I'll be happy to answer questions. But let's just take a look at the simulation now, and I'll move my face out of the picture. So here's the new format for the simulator. And I have the robot view and the course view displayed simultaneously rather than a toggle between the two. Also, the robot view is scaled to 1/2 its actual value. The robot view is where we physically sample the pixels. And in fact, we're seeing here, a little difficult to see until I'll request that the robot run. Let's do that so we can see the robot at start position. And in fact, then I'll stop the robot, freeze it in place. So here we have a schematic of the robot, and this is using a subset of processing drawing functions that we can draw an outline of our robot if we choose to. Also, we're seeing the sensors that have been defined. In this case, I have 3 spot sensors and a line sensor that has a new feature, which is you can specify an arc radius. It's or rather a circle radius. So it turns that linear sensor into an arc of a given radius. So let's see. So here also we're looking at the client program, which is the program that you will modify the controller code and the initialization code. And so the client in this case isn't really displaying much. It's showing us the current sensor information as it's being read from the now arc or half circle sensor, but displaying it as a linear array of sensor spots. And also we can see what our target speed is and our target turn rate. And in this case, I did add a little bar graph thing here that just tells us that yes, it's successfully updating the server. And the server and client can run on the same computer, so it's not any big deal. It doesn't have to run across a network or anything like that. And the idea is that if you want to run this version of the program, yeah, I'll distribute a binary file. Also, the idea is that someone who wants to configure the simulator for contest, then maximum values could be put into the simulator, and it would then become a standardized unit. Okay, so anyway, Also, some of the things, new things that we have here is with the contests idea, we have the ability to request run, which asks the client to start run. In fact, I'll start it over. And let's see, I froze it over there. Oh, by the way, we have variable step rate, so we can slow down the simulator, but it doesn't affect the controller's view. In other words, here I'm taking about 1 or 2 steps a second, and the simulator knows no difference. It's just that we get to see things in not real time or slowed down time. In fact, we can freeze it and literally single step the simulation. And that gets interesting when you're in areas. In fact, I'll drag the robot, which I think I don't know if this is a new feature or not, but we have the ability to drag the robot in either view, and I can reorient the robot. And it's now starting to run, and that might be a glitch, I'm not sure, and the controller is not enabled. Might catch me here. Let's restart the run. And I'll see how well I can make it through things that I may not have everything complete. Let's see if the robot is in fact following the line. Good. Okay. So the controller is up and running. And yeah, I have not fully tested all the modes as far as single step and freezing the controller and so forth. So there may be a few inconsistencies, and that's things I'm working on this very day. Anyway, so here the robot is running, and another nice feature is I'll go ahead and I'll stop the robot, and we'll see if the controller starts back up or not. But anyway, as I was saying, we have the ability to reposition the robot in the course view, but also we can go over to the robot view, and we can also reposition it. So if you're working, let's say you were working on the acute angle here, we could actually easily set the robot up. Here I'm holding down the right mouse button, and I can control the robot orientation, and then the left mouse button, I can drag the robot. And I'm thinking I should be able to resume. Let's see if I enable the controller. Okay, so this controller probably won't handle this acute angle. It almost thinks it could, but obviously it lacks some of the brilliance of a good programming mind. So anyway, I'll stop. I'll turn off my controller, and I'll ask the robot to stop. Interesting. Haha. Okay, again, maybe some inconsistencies. But here I was just going to say the other thing is with the controller turned off, I have just created the controls that let you manually drive the robot, which is, we'll say, forward. We can accelerate in reverse. We can incrementally perform left and right turns. And then Carl made another request, and that really kind of needed to be within the domain of the robot controller dynamics, which is to be able to move the robot sideways. So this is a mecanum wheel type feature here, where we could actually move to the side, left or right. So this is an option for your simulator, where you can create a sideways target velocity, just as you would have a forward velocity. And even with a mecanum robot, you could specify a turn rate, although here it's an incremental turn. So you can turn your robot, but then you'll be able to drive either along the axis of the robot, the x-axis here, or to the side. I call it sideways speed. And anyway, so
thanks a ton. That's awesome.
Let me go back to the request run. And one other thing that's in process is if the contest is going to allow restarts, the idea that we'll have here is we'll have the cookie crumb trail, and then if by judge request or by user request the robot stopped, the judge will be able to reposition the robot and then restart the robot, and that may or may not work. Let's see if I can reposition here. We'll say we were having trouble there, and let's see if this is going to work. If not, I'm not too worried, because I am in the process of debugging. So I'll say restart, And it doesn't look like it did, but I'll give it some help. Let's see if this helps it. And no. Okay. The goal is to have to provide the client robot with an instruction to say, hey, I want you to restart your controller. I'm not going to give you any position information, but know that you've been repositioned on the course. And so it'll work almost like a request run, except the request run actually is allowed to specify where it wants to be on the course. So in this case, the request run actually is provided with XY coordinates and a heading that the client robot says, that's where I want you to put me. And it's up to the judge to say, yeah, okay, that looks like a valid start point. Anyway, okay, so with resets or restart, I guess we call those resets. So those will be incremented and tallied up. Anyway, when the run is finished, whether the robot completes or not, then information is written, including, and I'll find it here, a screenshot of the final state of the robot. And let's see, give me a second here in the sketch folder.
Hey, Ron, I was kind of curious about your current
we have,
configuration of
let's see. Oops, hang on, let me open up the picture. Okay, so this is the snapshot that was taken as the contest ended. So it gives us the start and final location of the robot. And the idea is we would have a complete history or cookie crumb trail history, and also indications of where resets occurred on the course. And so that would produce a snapshot, but also we have data available, so we don't have to go in and look at the look at the actual snapshots. So I'm recording here, in this case, being appended to a file, the username, which the user provides, and the name of the robot. In this case, I'm just calling it demo, and the total runtime, number of resets. And just for fun, I threw this in distance from start, but I'm afraid unless we have some qualification or the judge can type in a comment, that's fine. I'll have a comment field for the judge to make any comments. And then the course that was being run, which in this case, we may want to rename this, but this is what the current name is I have for Doug Parody's, I guess it's the 2011 course that we run against, that Carl produced an image and then I scaled it to 64 dots per inch. Anyway, so there's that. I know I'm just talking away here. I guess I'll try to shut myself up now. Let me find my windows here. But that's pretty much my presentation. And I'm going to open it up to questions in a sec here as soon as I get myself squared away. And turn my volume back up in case anybody's screaming at me.
Hey, Ron, I have a question.
Yes.
Your current sensor, it looks like you've got 80 dots in the arc.
Oh,
right?
Yeah, oh, 64, I believe. Oh, well, I should bring that stuff back up. Sorry, let me just bring that image back up in case of questions. One sec. Let's see.
And then the other question I had, it looked like you moved your I guess you could call them square sensors underneath the arc before you had them in front of it.
Oh, okay, yeah, that's
any significance to that move?
no. In fact, I wasn't using those sensors. This is just strictly a demo. Oh, and I will also just give a quick, sorry, start this back up. And let me get to the server, wait a minute, the client here. Oh, in fact, I'll bring up Will's trike controller here. So hang on one sec.
Which his is just a straight line, right?
Right. Oh, maybe I should, sorry, I'll bring mine back up first. Let's do that. Okay, let's see. Yeah, I shouldn't have got carried away with. Okay, actually, I'll freeze it. Try to freeze it. There we go. Okay.
It doesn't even look like it's looking at the spot sensors.
Yes. So these spot sensors are not being used, and this arc sensor is being used. And for this simple demo, yeah, I didn't. I have nothing in it other than a centroid. In fact, today for fun, I was going to go ahead and add a polarity to the sensor to indicate whether it thought it was on a black tile or white, and I didn't bother with that. So I pretty much have kept a very simple controller. And let me bring that code up just so you can see. And also the user init code. Hang on one sec. Find this. Okay. So user init code here, really the simulation step is fixed. Technically, I guess the simulation is defining it as 0.166, so it's a little not quite, anyway, slight difference. Okay, so the client really, there's a server has a port that has to match the client port. In this case, we're running on the same machine, so they're running on the same IP address. So this is code you won't have to mess with. Down here, just to get an idea, okay, this is all the same. The spot sensors are defined just as they were in earlier renditions. Here I'm defining a line sensor just as before, or I'm defining it but not instantiating it yet, I'm sorry. So these are objects that are not yet initialized. Then we come into user init code. This is new. You have to specify, at least to keep the judge happy for the contest, you specify your first and last name and the name of your robot. So that's something that you'll change. You take this code and change that to yours. And a start location and heading. So that's, I don't know if that's new or not, but that'll specify where the robot's to be started on command by the judge. And let's see, as we come down here, we have the spot sensors. And the only thing new here is this, this set that sets the arc radius. So you define your line sensor as you would have before. In this case, it's 64 elements. Technically, there's somewhere it might mention that the program automatically will make it 65 so that the sensor is symmetrical. So it's odd values are symmetrical, so it's not a big deal. This ends up being 65. So if I changed it to 65, it wouldn't make any difference. Anyway, so there's our arc radius. And then the other new items are, here's where we set our acceleration and deceleration rates. And if we try to exceed the simulator, it gets mad at us and tells us. In print statements, maybe later I'll come up with something a little more obvious. But anyway, we got our turn acceleration rate, and then we have our maximum speed and turn rate. And these are, I'll have to think about that. These are values I think the simulator will balk at if you try to exceed them, but also it has maximums, like I think 36 inches a second was the max that you could travel with the simulator. Okay, so that's that. Then the only other thing is if you want to define some static geometry, you use processing drawing commands. And here I have commands that draw robot geometry, and this is in robot coordinates, and those are in inches, and they're centered at the, I think it tells you here, robot coordinates. The origin is at the center of the robot. Do I mention that there? I'll make mention. I'll type it in later. So the origin is at the center of the robot, and tells you the coordinates and so forth. And then here, within a begin static and an end static draw, these are things that get uploaded to the server and don't change. In this case, the robot outline doesn't change, so I do it all statically. And then here, this method is called if there's any dynamic drawing to happen every frame. And Will's robot, there is. He displays his wheel, and in fact, I'll load his robot up, and we'll get to see that there is code in this dynamic draw. And then also, the user is free to manipulate a status panel and to do their own drawing on their own window as they'd like to or not. But I have some example stuff here, and nothing much other than I do draw the sensor array. I might make this a method that you just call. But anyway, so that's all the goodies there. And I'll shut up now, and I'll proceed to load Will's demo.
So on when you look for a, basically you need an X value to steer your robot with. Are you looking for like the minimum width of either a black line or a white line, kind of in the center?
Okay, that's up to you. So in this case, the sensor, you can see, currently what the sensor sees. Right. And it's got 65 elements, and right in here, we've got some zeros or near. The sensor returns value intensities between 0 and 1. And anyway, so the idea is, yes, you might want to design some rules on line widths. Now, of course, one problem you have is as we rotate. Let me stop this. Hang on. Let's see if I can freeze this. As we rotate the robot, of course, one problem we might have is
lines,
yeah.
Or shift them left and right, maybe.
Yeah, so there you go. If we get, for example, here we go. Yeah, there you can see with that orientation of the robot, which is pretty undesirable. Yeah, it looks like a strange, who knows what that is. Well, of course, that might be the idea where you need to think about, gee, I can't let my robot get in that kind of position.
Yeah.
But the other thing is, Ron, that on that robot, I think the outside wheel to wheel is only about 4.5 inches.
Right.
So it's really close to the line width, whereas a lot of our robots are bigger.
Okay. Right. Yeah, and that's now that whether that becomes a problem for the simulation as far as the field of view, that might be something that we could adjust as far as if that's an issue. I mean, if you decided, I want a schematic representation of my robot and it doesn't even fit now in this view, I guess that is a consideration that might need to be taken. And I guess really, probably it might not be a problem. Come to think of it, in the past I was producing this view at physical resolution 1:1. In other words, previously I had an 800 pixel wide by 600 pixel tall map, and that was 1:1. But now I've already scaled the view down by 50%. So I think it might be possible to process a larger area. Now, one problem you might get into with a slower computer or even a fast computer would be if we image a fairly large area of the course or a larger area of the course, it might slow the simulation down. But keep in mind that it's not going to affect the simulation. It'll just affect the performance of it being real time to us, because again, for each time step, the simulator does render the appropriate views, if that makes sense. In other words, it might only run 10 frames a second, but it'll be running at 1/6 of real time, but it'll be doing everything that it should be doing. In other words, each time step, the robot will advance, some increment. So anyway.
Ron, I think this makes perfect sense the way you have it. And, given all the switches and options and capabilities that it has right now, it's really rich.
Yeah.
So it seems to me that if I were you, I wouldn't spend much time on trying to add extra scale features and stuff.
Yeah. Okay. Yeah. Just live with the fact that for this simulation
this year. Oh yeah.
Yeah. And the other thing is, if your robot happens to be 12 inches wide or whatever, believe me, work with this.
Oh yeah.
Will advance, will help you out. And I think Will would be one that would say that this has helped his development on his robot. So he feels like he's moving faster. Are you there, Will, to comment? Uh-oh, Will is silent.
I think he's on mute. Or was on mute.
Oh, hey, Will, if there's a microphone thing at the bottom. There you go.
I just had to take time to find it. Yes, I think the simulations helped me tremendously.
Okay, and with that said, I will, just for fun, I'll load Will's robot. I don't even know how much, wow, I'm taking up more time than I thought. Let me just get his simulation up, and we won't, and if there's more questions, fine, I won't spend much time. This is pretty much what we looked at last month, but let's see, okay, hang on, let's see. Let me make sure I shut.
Hey, Ron, could you do one thing before you shut it down?
Sure.
Can you position the robot just into, you know, one of the white, black, white, black, white, black transitions?
Yeah.
And
like right there?
Yeah,
Yep.
yeah. So is your sensor, or sorry, is your current algorithm, is it going to look for the narrowest patch of one color near the center? How does that work?
Okay, the way it works right now, and so yeah, I'm not handing over my current rendition of my controller. No, and
Okay.
you know, I don't have any, you know, really. Let me think. When I first handed over this simulation, pretty much I was, I don't know if I was quite there. I spent about, I don't know, a few days working on my controller. Oh well, you know, but of course I've done this in the past. So with my robot, you know, I have another simulator that this is all new code. I didn't refer to any of my old code. So, you know, everything I have here is new, but I have the experience. And so I've been able to complete this course, but it's my robot is slow. I think I run about 4 inches a second. But you know, just to give you some of the ideas, yeah, I look for features. I look for, you know, multiple intersections with my sensors. I try to make a decision on what I think the polarity is. You know, if the sensor's mostly black, then I say, oh yeah, it looks like it's inverted. So I have some rules like that. And now the arc sensor is pretty handy. I'd recommend that if you want to get a leg up on, you know, the line sensor is good, but, well, put it this way, it's different and it has different capabilities. You know, one of the things about the arc sensor is it does help solve the right angle problem. You don't have to worry so much about a line instantly disappearing as you approach a right angle, like if we come over here.
Right.
So this situation, you know, is kind of a natural for this sensor because voila, here we have, you know, a line off to the right now, and so the robot would naturally want to, you know, rotate itself. Whoops, wrong way. As I try to, hang on, let's see, try to scoot it in here.
Okay. Let me ask you this. I think, Carl, correct me if I'm wrong, but you and I are doing a similar approach, where we do like an edge transform over the image. So it's just wherever there's a white to black transition, there's a line.
Right. Now
so
that's another approach for sure.
Right. And that gets rid of issues where you do transition from a mainly white region to a mainly black region.
Right.
You have the two lines where the transition, where the edges were, basically. So
yeah.
I wondered if
my
you had
first.
that.
Yeah, my first simulation, the one, and if I dig it up, I failed last month, but I'll dig around and I won't modify it. But my original simulation, and I believe I had it running, yeah, maybe not reliably, the course, but I do think was pretty close. Now that one used that idea, yeah, just an edge transition idea where you don't care about the actual polarity, you don't care, you know, if this is white or black, whatever, black, white. But the one thing I did find is if I approach a region and I'm not aligned well with it, I tend to get a moment of confusion anyway. And I tend to say, oh, I don't know what's going on. Well, that's at least, you know, I'm seeing too many things, weird things happening. And in the past, what I've done is I ignore it for just a little bit, and gee, things tend to get better pretty quickly. So it's that frontier you're crossing. And depending on your sensor arrangement, that frontier could be confusing at that moment, but it's one of those things where if you don't make any radical changes, you might be able to get yourself into a better situation. So sure, that's a definite thing to look at.
Yeah, I call that headless chicken mode.
Oh, okay, that's good.
And it goes crazy and then it calms down. You know? was thinking of even putting a little bunch of loose feathers on the top to kind of, simulate the movement of a headless jig.
Hey, Ron, I have a question. When you're in I want to make sure I understand exactly how the sensors are being read. Let's say you're in one of oh God, what do they call them? One of the areas that has not black and not white.
Right.
A stain area. I want to make sure. So the sensor reports a value that's not black or white, right?
Right.
And then it goes ahead and it takes it and does the averaging of whatever the sensor, the little sensor node is. I think you're using 25 pixels. And comes up with a value that says, okay, this is, as long as it's greater than 0.5, it'll become black, and if it's less than 0.5, it becomes white or something like that.
Well, it reports to you. Yeah, what it reports to you is, and let me think.
I see it here. I see it in your thing.
Yeah, there you go.
Yeah.
Okay.
So you
can
still look for those darkest pixels, right? And find the line.
There you go. You might, in this case, you can see, you might be able to reliably do that for sure. So yeah, don't use the supplied idiot algorithm. Come up with your own potentially to evaluate a grayscale situation. Yeah, right now I'm not doing that, but with my simulation code, excuse me, there's nothing there. But that's an option. That's certainly an option, yeah. To look
the value, the intensity of the sensor node is reported.
Yes. So the values that would be recorded here, and I'm displaying them here as intensities, but if we went and examined them, we'd have zeros here, 1.0 here, and then intermediate values here. And I am just out of, I had some early problems with synchronizing data being sent from the server, so I just quickly said, oh, the heck with this, I'm going to make everything 1 byte, and I didn't want any fancy syncs, stuff. So I think I scale these values. I think 253 parts. I reserve a couple of byte codes for beginning and end of the sensor data, but pretty much more or less you get an 8-bit intensity value minus like 2 values. So it's the complete dynamic range of intensities from black to white represented from 0 to 1, but it's technically 0 to 253. So you're just about 8 bits, 7.9 bits of resolution on intensity, we'll say.
1.9.
Yeah, I made it up. Okay.
I have a question. Ron, my name is Jian. I think this is the first time I see you. But yeah, I'm using the simulator. I have a question about, there's two. One is how, the version I have, the robot will keep going. And I wonder, does it stop at the loop completion or like crossing the finish line? Or,
that's up to you. That you would have to detect. You would have to detect the finish line. So in other words, and that I do have a detector in my current rendition of the controller. I think in my current rendition, I think I have multiple arcs. And come to think of it, and I have an arc that's pretty nicely sized where I get an intersection here, here, and here. And that lets me know it's one of two things. It's either the finish line, or there is another case that looks the same. But it turns out that my outer arc misses that that line, and I can tell the difference.
I see. So it's really up to the robot to stop or not.
Yes. Yes. Yes.
Part of the secret algorithm.
How do we count
time? That's
right. I mean, like during the competition, is there a judge say, time off, like it crossed the finish line? Or
Can he be bribed? I think is your main.
Yeah, that I don't know. I don't know the rules to this. That's something to ask the rule people. I don't like rules very much. So,
Doug?
but I have noticed they do this thing where if your robot messes up, they give you a chance to continue on, and that's what I started working on here. Where if your robot goofs this up, then we say we're doing I believe they call it a reset, and I'm going to put an R there with a circle, I think, and then but I don't have that yet. And that will that'll allow the visual record to show what happened. And if no one completes it or whatever, we might, I guess the judge might say, oh, somebody had just one reset but did the whole course. That's worth more than not doing the whole course, sort of thing.
Yeah, better let a human figure this out.
Actually,
Too much rules. I have another question.
Rules right now don't allow that. Essentially, who goes the furthest? That's
Oh, okay. Who goes? Oh, is that the? Oh, sorry. Oh, so I don't need to work on this restart nonsense.
well, you can. I'm sure there's going to be people who want to do it, but with the simulator, I don't see the point of it because either you do it or you don't do it. So
okay.
I think with the simulator, the restart makes it could make it easier to just pick up where you were and look at something and keep going.
Oh yeah, no, that's definitely the idea here is not necessarily right, definitely. And right now the goal, things are a little bit goofy because I have been playing with the contest running stuff. But the idea is you'll be able to come in and set your robot up. And I think the way it works right now is if you position it, you can like reposition your start. I mean, you can manually go into your code. And I might create a demo of that. That would be a nice demo just to show you how you could program the thing to where you can either press keys or whatever. Usually when you're working on a feature, you're working on a feature. But let's just say I'd give you the ability to have different points. Like, okay, this would be the place where you might want to be to test the acute angle, for example. That would be a good starting point. So it'd be nice to remember that. And if anything, I was just going to illustrate in the code via like a case statement where you could find these locations. Like right now, I could write this down: 36, 26, 210 degrees, looking at the current location, and then just create a setup with that. And then, then another popular one might be, whatever, running into the first stain. That one usually is fun for me. Okay, so, I would set that up. So 11, 140, 287, and just have a statement that sets the robot up. Then I would just go into the program manually and say, okay, do that one or do this one, if that makes sense. Just pre-program some start positions, because obviously, once you get your basic robot running, you'll have whatever trouble spots. Another one might be, okay, I want to test my gate code. So here I might want to position my robot here and record that 6919, 03 or something, and throw that in the program so that I can say, just real easy, go into my controller and say, hey, start here. And then, for the 10 times it takes me to go through this to get it to do the right thing, I've got that. So if that makes sense.
Hey, actually, that answers one thing. I was wondering about debugging. The way you say the state of the simulation, is that everything, the location, angle? How many? Can you list like all the states? So if I set these variables, it's gonna do the same thing like every time. Yeah.
Okay, if I'm understanding correctly, one thing during competition, and this is another sticky spot on competition, is I was thinking it might be nice for development purposes to give you the exact XY locations on the course and the heading. But for running a contest, if anything, the problem is we don't kind of want you to have a perfect little simulator as it is now, because believe me, you could take this thing right now and save your waypoints, run the robot through and just run a waypoint contest. But that's
I got it. Yeah.
Yeah.
So you want to introduce some variable. I mean, some variation each time in the run. Right? Is that what you mean?
Yeah.
Oh, okay.
Yeah, that's kind of the idea. And my thought was, for example, the robot won't run perfectly straight, and I'd like to give that some thought. Maybe and maybe something that isn't exactly something that you could that would happen the same every time. But it needs to be something that everybody would feel good about. I mean, I would take a standard case of if I run a typical robot, from one end of the course to the other, I might expect some deviation from a perfectly straight run. And the goal is that it just wouldn't be that difficult to do this as like a CNC problem, where you're just driving 9 inches, make turns whatever with some given radius. That could be done right now, and it's not terribly exciting. I guess the idea is the general idea of the course is you're using your perception based on sensors and not maybe based on some short-term odometry. That sounds reasonable, where your robot does have reasonable ability to know that it's driven forward 12 inches, that sort of thing. But it doesn't have the ability to know when it's over here what the XY coordinates of the contest course are. But it might know if it recorded what it thought its current position was here, and then it drove to here. Yeah, it's going to be within some small error, if that makes sense.
Yeah, my question was kind of oriented for when I want to debug some scenario. I can go back and repeat what happened earlier.
Yes. Okay.
Yeah. So just wonder, how do you do that?
Okay. Well, one thing to be said here is running in a non. I'm finding my thing on my windows here. Not that I need to see myself. I'm getting lonely. The idea too with the contest is if there is some variability that's proposed or produced in the drive of the robot, you can also turn that off. And in a non-competitive environment, I'm certainly game for saying, okay, the robot's going to drive straight if you give it 0 rotation rate. So in other words, that would give you repeatability. Now in the past, the very early rendition of the controller was such that typically, or one example of it, and in fact, Will's trike kind of uses this, but that's easily fixed, where you would start up your controller, then you would manually ramp up your speed, with a button to say, okay, speed up the robot. And the problem is that introduces variability. So really, as long as you have a programmed, I set my target speed to 6 inches per second right when the simulation starts, and my position is X, Y in this heading. And if we turn off any variability in the simulator, making one wheel a little smaller, making the thing rotate as it drives, that sort of thing, then you'd have repeatability. It should be deterministic. Yes.
To answer his question, unless you've added it lately, there is no state information recorded and available for troubleshooting.
Oh.
The simulation doesn't
say again, Will.
Retain any. You do not have any state information retained when your program stops. It's gone.
Okay, so it's up to you, but no, wait. It's up to you, or it could be up to you, to record state information. In particular, if it was a non-competition setting, then you have your own controller state information. You know where you started, and I think in a non-competition setting, I see no problem with providing the simulation result, which you could include in your code. I mean, you can literally embed your own robot dynamics that's doing what the server is doing. In other words, I'm saying the thing that updates the location and the heading of the robot, you could actually run that on board your own client. It doesn't, but as long as the server isn't trying to alter that data a little bit. Now, am I saying the right words, Will? Uh-oh.
Yeah, that
No,
answers my
well,
question.
unless you've added it, there's no state data reserve saved for you.
Yeah, no data is saved. You would
That's-
have to do it.
Okay.
The only thing you can do it there, you can print stuff to the monitor. You'll see that if you run my display, you'll see down in the lower
We'll do that.
right-hand corner that I'm printing out
Okay, one sec.
information as it runs. But even that's kind of fleeting. So the answer is there's no state data saved, at least currently. Okay?
I realize now. So we kind of can specify the target speed, but we don't really know the actual speed. So yeah, maybe there is some internal state that the user doesn't know. But I don't think it's going to be necessary to know everything to the exact point. Yeah, I mean,
Well,
yeah,
Well,
thanks.
you do know.
Well, I guess with the code at hand that the server uses, though, I mean, as far as by that, I mean, given that at step 1, you know, we specify some target speed and with some acceleration, you could have that code running on your client that tells you exactly what the robot's doing. But again, the goal will be to make the simulation behave just a little differently, just so that you can't track your exact position and heading throughout the course.
You wanted to model the real world, which has noise.
Yeah, exactly. And to be honest, one thing, you know, I think just to make it look common, it would be, yeah, some differential rotation based on forward speed for the differential drive robot. Here we're seeing Will's tricycle robot, by the way. So here Will has really his wheel, which is maybe a little hard to see, but that is being dynamically drawn every step via, you know, he's sending drawing commands to the simulator every step. Just to
I guess one of the things I'm thinking, Ron, is there's probably needs to be a judge panel down here, you know, where you can turn it on and off, and where the local X and Y and angle are completely not available in a competition.
Yes, definitely.
Okay, so that the person can't really do that.
Right, definitely. That's the goal.
The other thing is in that panel, it might be better to or a file or whatever to allow a person to you know, if I set, say, a 20 millisecond loop time, since that's longer than 16.66, that would be acceptable, right?
Okay.
Is that correct?
As of right now, that wasn't considered, but that to me seems fair.
Okay. So now one of the things I'm thinking is instead of putting it at 16.66, make the max, say, 100 hertz. Okay, or 0.10 milliseconds. I mean 10 milliseconds, and then let the person specify where they want their loop time to be, and
Right.
they can make up to 10 milliseconds, but that's the fastest they can go.
Right.
And the timer, I assume the timer is based on the count of DTs.
Yes.
Okay.
Yeah. So right now it's counting at whatever it is, 16.6.
Yeah, and I think stopping the robot, that could be the judge's responsibility, and the person doesn't really have to detect the stop line. That's just me, but we can do that either way.
Doug, I think the way I'm going to handle that is I just won't update he'll call me at 100 times a second or 60 times a second.
Yeah.
But I just update mine every third or every fourth times he calls me. So that's how I'm going to slow mine down.
Oh, well, I'll tell you what. I'd prefer if you tell me what you want the DT to be, because I'll tell you what, if you pick it slower, the simulation will run faster. So in other words, if you run a a 20 millisecond update rate, that's handy, because then I don't generate any, at the end of the day, I guess we generate the same number of updates, but let me think about this. It might give me the ability to achieve a faster frame rate. I don't want to, ideally we don't need redundant frame drawing. Let me think about this. Yeah, if you are, go ahead.
I was going to say, I think you should only be responsible for setting maxes. Okay, and otherwise the person in the robot controller has to set their actual.
Right. That's fair.
And then that way you don't have to do much. You shouldn't have to do much. And that just overrides the value.
Well,
right.
Just a second. The thing that Ron is saying is that if he actually uses your value, which is less than the max, that it allows the simulator to actually run faster because he's not having to do as many updates.
Well, that's fine, but I mean,
I wouldn't worry.
The simulator rate is not an issue.
Right. Hey, just don't even give it a second thought. Let me implement it, and I don't think there's any problem. I get it. So,
Ron, I think you just define the API, and it'll be our job to code to it.
Right. Well, there's just that's a good one, and that's no problem. For some reason I had it as a variable, and then for some reason I started deciding, let's make that fixed. But yeah, I don't see any problem. Yeah, we'll just have like you say, a max, and you can specify what you want your delta time to be, and that's fine. And the thing already is, go ahead.
Well, you don't want to slow your simulation down, because then that gives you a problem when you're calculating the XY position of the robot. You need a flat up.
No, in other words, no. If you specify what's your delta time, there's where you're messing up there. I mean, I'm just executing the frames don't, the frame rate and all that stuff doesn't matter, because physically, I mean, we execute the simulation step, with some given DT, whatever you specify, it doesn't matter. Hang on, let's see if I can show that.
I mean, this is a classic issue of sample rate in arbitrary sample period time, and how that maps to real clock time.
Right. Well, the thing is your simulation might look like it's running a little bit weird. In other words, if already the problem we're up against is we may be up on some computers with the problem of not being able to complete a simulation step within one drawing interval, which is typically 60 frames a second. And so that will create sort of a little bit of an inconsistent look about the run speed of the simulation, but the simulation will be good. In other words, if you're saying I want 1/10 of a second per simulation step, well, every 10th, we're just increment, we just ask you 10, well, it doesn't even matter how frequently we ask you, and I know that your delta time is defined as 0.1 seconds. So when I apply the computations, it's fully disclosed in how it's being done. It's just a simple, like a first order.
So this, at that point, the simulator won't run in real time, but it'll run correctly, just
right.
Except that it won't be in real time.
Correct. And I may need to, if there's a significant difference, let's say you said, I want to go at 10 frames a second. Well, technically, if the simulation is able to, it could run you up to 6 times normal speed. Well, let's just say my typical frame rate is 60 frames a second. I might be able to redraw the robot image, which is the thing, and then extract the sensor data all in a 60th of a second. So it does invite the possibility of running faster in real time. Whoops, sorry. Somebody trying to speak.
Well, Ron, if you just go ahead and take whenever the computation is done, then you do the display. When the display is done, you can do the next computation, and therefore the rate at which it gets updated on the screen is determined by how fast your computer's running.
Right, and it gives you the option there of saying, well, if my computer's able to get that 1/10 of a second step done in a 60th, you have the freedom to run your robot visually faster than real time. But nevertheless, it's still doing what it would do if you slowed it down.
How fast can you run the simulation of this course, Ron?
Well, right now, Dick, I'd say about.
Well, no, I've got no. If you could, I'm just saying.
Oh,
I've got. If you got a high, I'm still talking. If you have a high end computer, could you just start from the start, and it only takes 4 or 5 seconds to go through the whole course if you're running at max speed?
Theoretically, yes. But maybe so far what I've witnessed, now I'm running an intermediate, I'm running an i7, like, I don't know what it runs at, 3 or 4 gigahertz. Probably, I'm guessing, a single core is what's processing the data. And, the images are being offloaded to GPU, but I suspect there's areas where things could be done more efficiently. So with that said, theoretically, yeah, a fast computer could run the simulation, much faster than real time, and that would be nice, certainly desirable, where you'd have the ability to say, hey, yeah, go ahead, help yourself, run it fast, unless I need to slow it down. And of course, often that's the case with diagnosing problems. And of course, I do have the ability to slow the step rate way down for careful analysis, including single step, where you're going 1 delta t, in this case it is 16 milliseconds, but that could happen every 30 seconds as you look at the thing and what is it doing.
Another question I had was, I'm a little confused. I'm not sure, can you adjust the speed of your robot on the course as it's going? So like when you're making a tight turn,
Yes.
You might want to go slower?
Absolutely.
When I'm looking at this center display, it says wheel speed 3.9. All it's ever shown is wheel speed 3.9. That's not something you set up initially.
That for Will's robot, it is his wheel speed.
That's
how he runs
client
his simulation.
definition responsibility, right? That's how you define your robot capabilities and behavior. So that's Will's robot you're showing right there, Ron.
That's okay. That's Will's robot, but here is my simple demo. Is an example in this controller update that's called every time step. In this case, I do calculate a speed based on, it turns out, an error. If the error is small, it goes faster. If it's larger, not well thought out there. That function may not be that good. But anyway, so that's an option. Yeah. And the other option too, and this will be documented, is you can also change your sensor locations dynamically, which is sort of in line with what you might do with a video robot situation. Of course, you may do very elaborate things, in which case maybe the simulation is a waste of your time. But you can vary, for example, the position and like the radius of the sensor dynamically. So just for fun, if that's something that you think would be useful, you can do that in real time. You can change those parameters.
Well, how many sensors can you have on a single robot?
How many? How many do you want?
I'm confused. I saw initially you had sort of that arc sensor, and then it looks like on Will's robot, there's all these different little green boxes. I assume those are all different sensors. Right.
Those are spot sensors. And so each one of those just returns a single value. Of course, this line sensor is probably something like 64 pixels, 64 spots. And so yes, you could have more sensors. Now you might get disgusted with the run speed if you add 50 lines or whatever. Then
Ron, you don't have any limitation, right? That's purely limited by what you decide to code when you define your robot.
That's right. But you may be disgusted by the performance, and
Yeah.
you know that would affect your development speed, I think.
Okay, just for a checkpoint, the rule says right now, as it currently says, you can have 4 line sensors and unlimited spot sensors. Okay, and the reason why it was picked at 4 was because we had modified the processing version of this code to actually display 4 line sensor pieces of information. You see where his says N65, you know, you were allowed to have 4.
But a video camera has 240 by 120, right? So
there you go.
No, well, I'm just going to try to say is if it's really not meant to, this one here isn't really done to meant to have a video a spot sensor can be a video rec sensor. If you wanted to, you could set up a spot sensor that was 120 by 240, and you'd get 1 value for that sensor. Or you could set it up as 1 pixel by 1 pixel. It has to be an odd number of pixels. And you could have 256 spot sensors, and you would get an evaluation with an XY coordinate for each one of them. So, I mean, yeah, you can do anything. Now, realistically, having played with my real robot, the amount of pixels that you can sample, at least in MicroPython, at a reasonable frame rate, is going to limit you from doing a whole. You can't just say, read each individual line and tell me each point. You can do what Ray's doing, which is, you know, you can extract edge from the real sensor and other things. But if you're going to use, if you're addressing individual sensors or individual pixels, there is a maximum number that before you start impacting your rate, your sample rate,
but
frame rate.
But it doesn't really impact the actual simulation, or at least I should make a note of that, though, that the original simulation was tied to frame rate. So in other words, now it's not. So I think I had a comment in there that said, hey, if you want your simulation to run more consistently, then do not use the frame rate, because if it takes the computer half a second to draw the next update of your simulation, you're in a bad place, because now things like turns and things like that are going to be so crudely estimated by the simulation that you'll have great amounts of error. You know, when it's running around a step time of we'll say 60th to 100th of a second, at least I've introduced a turn rate and a forward speed, and the thing will sit there and trace circles out on top of itself, you know, almost indefinitely. So I feel like, gee, that works pretty good. But I'm sure if you bump that sample, the DT up to, you know, half a second, you might be disappointed in how the robot performs.
There's another question that came from Dave Anderson, and this really probably goes to Will. Dave Anderson wanted to know is, can different types of robots be used on this simulator? And he especially said an Ackerman. When I told him, well, an Ackerman is essentially a trike, can be simplified to a trike, and that Will has a trike that's backwards. So the thing, but the real question is Will, in your robot, is the rate of the turn axis is still the origin of the simulation or the robot simulation, 0, 0. But is it being steered with a moment arm of whatever your wheelbase is? Or is it?
Are you
like
asking me a question?
Yeah, well, anyway, you or Ron. What I want to know is, okay, he made the observation that if you were modeling an Ackerman type robot, that the turn radius would be the same regardless of the speed of the robot. Where
Well, that's
with
Will's.
differential robot, it would change with speed.
Well, look at the code in front of you there, Doug.
Okay.
Okay, see, in the case of Will's, well, I can let Will speak on this.
Yeah, I see the
Here,
difference in it.
Yes, it's true that on a Ackerman or on mine, the wheel angle sets the turn radius, and it doesn't make any difference how fast you're going. In fact, my whole code for my robot is based on distance traveled, not time. So basically, it should perform the same whether I'm going fast or slow. But that's built into my code. That has nothing to do with the simulator code.
Well,
In fact,
but
the
it
simulator doesn't really model a robot. All it does is odometry, because your robot needs to send the simulator a rate of turn and a speed forward, and then it performs odometry and puts itself on the screen. But your dynamics of your robot needs to be in your controller.
That's
Okay.
what I pretty much told David. But so
Yeah.
what I'm saying is, what you're telling me is that this doesn't preclude somebody modeling an Ackerman type robot. If they
No,
wanted
it
to.
does not.
And it might be a good example because Will's got the code right here. If you notice, he's got his wheel speed here. And if the steering angle is 0, then the robot is driving, set speed is getting the wheel velocity. So if the wheel velocity is 3 inches per second, we're going straight because our steering angle is 0, then our forward speed is going to be whatever I just said, 3 inches a second, whatever. Okay, so as you turn, now let's just take the extreme of this. Let's take his tricycle and turn the wheel 90 degrees. I don't think he allows that, but let's just turn it 90. So now our forward speed is going to be cosine of 90, that's 0, times whatever his wheel speed is, 3 inches a second. So now the forward speed of the robot is 0. And then the turn rate will be, it turns out, will be equal to the wheel velocity, because the sine of the steering angle, divided by the wheel base. Okay, so that's the so the wheel base that's the difference between the front wheel and the pivot point in the robot. In his case, that's 3. Well, I think it's 4 inches. So it is dependent in this case of how far the wheel is in front of the rear wheels.
Right,
So if it's
that's yes, and that's what I told Dave. I just wanted to make sure I was telling him
so
that it was a good thing.
Yeah, this function will handle it for you. I mean, you can just recraft it. I assume. Correct me if I'm wrong, Will. A tricycle and an Ackerman steering pretty much are going to be the same thing, right?
Yes, except they would typically be a forward steering, so you'd have to change the signs in like when he turns right, the robot goes left or something, and you go right, turns left. You have to get that correct.
I think just as an illustration, I will provide an example of that, including the little bit about the drawing commands. So I'll show you a little schematic of your wheels. So as you turn your wheels, it'll display that, so you get an idea of how to do that. The dynamic graphics. Although when you think about I could do it with lines. Maybe I'll add another feature where you can draw a rotated rectangle as I think about it, trying to think how to make things simple. But I'll create a demo of that since that's popular. One thing we did run into is Carl made a request for the Mecanum wheels. And now the simulation as it is as a differential drive robot would not be able to handle a Mecanum wheel without the ability to instantaneously turn one direction, drive that direction, and turn back. So since the simulation isn't allowed to do that with its differential robot, I added in the horizontal component of speed. So in other words, your robot, if you have Mecanum wheels, you could have a forward component, we'll say 1 inch a second, but you might have a slide to the right component of 1 inch per second. And hence your robot would not be rotating, but it would be translating, in this case, at a 45 degree vector. And then, of course, in addition to that, the robot can rotate. So anyway, so that was the point. I did add that what I call sideways speed into the simulation. It's available if you want to use it.
Yeah.
Okay, guys. Cool.
Okay, have we said enough?
I
Just
have
a bit of a time. One more question then, John.
All right, thank you. Do you guys, maybe Ron, do you recommend remembering the state of the map? Kind of that the robot is remembering the path. When it comes back, it knows, well, I mean, for example, there's a bifurcation point. It'll know, it's like navigating a map. It knows, oh, I took the right turn last time. It didn't work out. I'm going to take the left turn now. So do you guys think it's a good idea?
I believe in short-term memory or sensors that don't require memory. And that's the beauty of, we'll say, a line or an arc sensor where you can do an evaluation and perhaps a time step later do an evaluation. But long-term memory, I personally think that's tricky. Other people can answer that.
I agree with you. That's making it really complicated, more than it needs to be for this course.
But what if the course has a loop where the robot will just
yeah.
Well, like this course does if you screw it up.
Potentially, if you screw that up. Yeah, now that might be an argument for short-term odometry to say, gee whiz, what am I doing? That would be, maybe fault detection where you might have some rules that say, hey, there's something squirrely going on. I was faced this direction at this point roughly, and not too long later, I'm faced the opposite direction. Maybe but boy, does that get complicated, I suppose, to try to unravel what's going on. But those are possibilities.
Yeah,
your choice.
We need to make sure that nobody can just map the course. That's the one thing we want to get away from.
Right.
The other thing we might want to do is anybody who successfully completes it has to show the ability to start randomly in a random location on the map and continue to actually do something. You know what I'm saying?
No, don't say that.
So, I mean, I don't want somebody just saying, okay, well, after I do 12 inches, I'm going to turn a little bit to the right.
We have a problem here, Doug. It just so happens right now, my acute angle detector, once it's used in the course, it burns out. I mean, it physically, the code shorts out.
Yeah.
So I don't like your ideas. I think I could work.
It would still be, if you started your robot in another location, you would still have one arc turn available to your thing.
No. Oh, I'm sorry. Acute angle. Yeah. So the idea.
Acute angle. So it should work.
Well, see, here's the thing: the acute angle detector. It's good that it burns out, because sometimes in here I've thought I had an acute angle, but now that my acute angle detector has burned out, which it always does, quite reliably, then I'm better off because I never think anything else is an acute angle.
It's a feature.
Secrets of how to get through the thing.
So those are just constraints we need to get into the rules. But yeah. Intense there.
Yeah, just now you guys were saying the short-term, long-term memory. Do we allow memory carried through from one course to the next course, like the first run to second run? So my meaning is I run first time. Can I remember something so next time the next try is better?
Well, that's an interesting
thing. On the simulator, I wouldn't think. Simulator is a restart. When you hit start, it's going to.
It depends on how your controller is written, right?
Yeah, I agree. I don't think I would preclude that, and especially if the job is done that prevents you from just creating a waypoint list and executing it. That doesn't. I
think you're over specifying it though, or at risk of it, because one solution might be a neural net. And the neural nets require training, and the training require knowledge of prior runs. So I don't want to see the rules precluding novel solutions like that. I want to see the rules precluding, like you said, Doug, somebody says, well, I go ahead 2 steps, left, right, one step. We don't want that. We want more better solutions.
Basically, should follow the line.
Yeah. End of the day.
In the end, the line is the sensor that it's using to determine its direction.
Well, Will argues that this is not a line. This discontinuity, is an impossibility. But anyway,
I would say it's a path then.
Ish. Okay.
Okay, guys.
All
We gotta
right.
set the philosophy aside, or we're gonna run out of time.
Okay. Sorry, Carl. Okay, get rid of Ron.
It's all right. No, thank you. That's
Thank you,
awesome
Ron. That's
update.
fantastic. When do we
Really
get?
good progress.
When are we going to get a copy?
Soon.
Okay.
Cool.
Just like a couple days, maybe a day.
All right.
Volunteer work. I'm not complaining, Ron. When you can get it going, let us know.
Okay. Okay, so get rid of me. How do I unpresent myself? I do that. Okay.
You just stop presenting, and we're good. All right. And let me do a time check. I can't remember. Did we schedule till 3:30 today? Is everybody good till 3:30?
Yeah.
Okay, I'm seeing mostly nods, positive nods. So I'll target for about an hour. Okay.
Yeah. Sorry, Carl, if we cut you short.
Yeah, it's all right. It's recorded for whoever wants to see the recording. And I can do it again. Okay. So I am now going to present. And are you guys hearing me echo, or is that just me hearing my echo?
You sound good to me.
Okay. So I have something funky in my setup.
Can you turn your volume down a little while you're, that helped me. I shut everybody up.
My setup is really weird today. It's not that. So are you seeing my screen? I mean, presentation? No, I see.
Wait a minute. Okay. Did I get rid of me? Okay. Did you say present now?
I did.
Look up in the upper right. Are you pinned? Unpin yourself.
No.
Or switch. There's 2 things.
Don't tell me my great plan will fail. Okay, I got to come right back in just a minute.
Yeah, you
got rid of Carl. I couldn't take any more of him. He had way too much to say. I don't like that Carl at all. Oh, he's back. Oh, he's muted. Unmute yourself.
Okay, is my screen being presented?
Yes.
Okay, good. And you can hear me?
Yes.
All at the same time. Wow. All right. Okay, so I have some really funkadelic things going on today. Like I mentioned before the recording started, I got no less than 6 screens to host the meeting and do this presentation. So, all right. Okay, so you should see the screen now that says DPRG September 12th. Okay, so what I'm going to present now for the next little bit is about web meeting, broadcast, and recording tools. Why? Why in the world are we doing this? Well, we like to share our robot projects like Ron just did. And it's often handy to mix and switch between different views, whether you're looking at code or console output, telemetry, right? Just the mechanics, how your thing is built or made, how the robot moves, how working in action. Maybe you got an onboard camera and you want to watch its video stream. Maybe you have intermediate OpenCV output computations. Or maybe you just want to use a better camera or one that's not stuck to the screen you're using, like a phone camera. So give me a moment. I'm going to turn my volume down. I have latency in my feedback ear. Okay. So the basic premise here is that you might have something to show coming from a lot of different places. Maybe it's a camera. Maybe you got a recording. You want to use VLC or some other player, static image, text, presentation like this. Or maybe you want to have one of these NDI streams. We're going to talk more about that a little bit later. You got audio from different sources, which is driving me nuts because of some limitation in Google Meet. I can't do what I want today. Meet and my laptop are conspiring. So all kinds of different sources, right? And the whole idea is that real time, you might want to modify them a little bit. You want to mix them and overlay them and switch between them. And then you want to shoot them out somewhere, right? Maybe as a virtual webcam and feed it into Zoom or Google Meet or Skype. Or maybe you want to do it as a file and save it. Or maybe you want to stream it like Howard does for Twitch, or you got a YouTube channel, Facebook, or again, one of these nebulous NDI streams. So that's the basic concept here, and that's what I'm going to talk about today. Now, in the past, you think about broadcast video, and you got this production control room, right? You got this team of people, lots of screens, and then you got this central apparatus room with all the gadgetry that does the hardware mixing and streaming. And we're not going to do that. We're going to do this. We're going to grab a laptop, and we're going to accomplish a lot of the same things. So I'm going to show you two different tool sets and ways to get there. There's some overlap between them, but they do have some unique features. And what's cool is that they're interoperable, though. They can work together. Just keep in mind that what I'm going to show you, there's some learning curves involved. And they can definitely hog your laptop or your network capability bandwidth, especially if you're trying to do Wi-Fi, especially if you're trying to do higher resolution video. Things can start to get weird fast. So the first thing I want to show about is this OBS Studio. And this is a shareware open source project. It's free. You can get it Windows, Mac, or Linux. And it has a screen kind of like that below. And that's where I'll spend most of the time in the next half hour, an hour. The other thing I'll mention, we'll touch on it, but it's called NDI Tools. I think it's a company called NewTek. And what they have is this set of free tools. You got a runtime, this tool set, and then they have an analysis beta thing they call. And then they have these apps, two different apps. Now, they appear to only be for iPhone, but at least you can find some NDI interoperable third-party stuff if you look hard. They're kind of pricey, I suppose. This one is $20, this one's 10. But that is a start of, I mentioned these earlier in the year because until the end of May, they offer these for free, thanks to the COVID crisis. So I've got some free copies, and I think they're really well done. But anyhow, back to OBS Studio. Let's start here.
Was that price per month?
That's purchase price. It's not a recurring subscription.
Okay.
Yep. It's a one-time purchase price. And if you do it a lot, I think it's well worth it because they work so well. And I even use this one. Like my mom has an iPhone, one of my hand-me-down iPhones, and it's really hard to help her out when I can't see what she's doing. So I have her turn this on, and then I use the free version of TeamViewer, and I can watch what she's doing here in Dallas. I can see what she's doing in Pittsburgh and talk her off the ledge. Okay, OBS Studio. So I'm going to show simple tour and a demo. Well, I say simple, but what we're going to do is we're going to play around with combinations of a camera or two cameras, screen, text, audio. I'm going to show you how you can mix them all together, switch between things, and then we're only going to worry about one output for the moment. And we're going to touch on these concepts. I'm going to walk you through what they call scenes, sources, mixer, transitions, studio mode, and then how you can locally record. Because one cool thing about this is that you can do screen, you can screenshot, you can screen scrape your desktop and record it to a file as a movie for free. So, and then I'm going to demo outputting it to Google Meet. We're going to mix the title overlay with the camera, transition between some screens, and I'm going to mention chroma key, which you may know as green screen. Just keep in mind it doesn't have to be green. All right, so let me slide that to this other screen. Let me slide in my control panel. All right, so you should now see my smiling face. And this is the OBS console. And I'm looking to the right because I can see what you're seeing on a presentation. So basically, this is the basic simple view. And what it's showing you is, this is kind of like, think of it as a compose window. And I'll get into the details of it in a minute. Then you have these parts down on the left, you have these different scenes. And then for any given scene, like right now I have, you can see laptop camera only unfiltered. And it has one source called a laptop camera. And just to confirm, are you guys able to read the text? Is this big enough, clear enough font? I see some nods. Okay, good. That's thanks to this hairy-ass trick I'll show you in a minute later, but I'm showing you this at full 1080p resolution. And that's where you can read this small font. Okay, then, so you got scenes, multiple scenes. Each scene can have one or more sources. And then the scene also has an audio mixer. Now, because the audio is screwed up or really messy in the way I have everything hooked up right now, I have all the audio zeroed out. But what you can do if you have multiple mics and different places audio is coming from, if you're using it different than this demo, you can bring them in and level them and pan them left to right and whatnot. Okay, audio mixer. Then you have scene transition. I'll explain that in a minute. And then you've got these controls over here. We'll also get to that in a minute. So the scene sources mixer. Okay, now how would you use those? Well, like you can see, this scene is called laptop only camera unfiltered. And the one below it is called color key Carl's office. So what happens if I click this? Oh, look at that. So it turns out that, like I said, it doesn't have to be a green screen. It can be any color. So, and you'll see that on this particular scene, laptop camera. Okay, it looks like it's the same, but if you go look at its settings, somewhere in here, no, it's over here. Where did it go? Filters. So if I right click on this scene and I select filters, now you can see that I have a chroma key applied. And with the chroma key, you can change, you can say what color you want to be the chroma key color. And you can say how similar do I want it to be. So what it'll do is it'll look for real time, it'll look for colors which are similar to the one you select. And then it'll say, well, that's what you want to be as green and what you want to have mask out. And then what I could do is, with the chroma key now, I can say, let's add another source to this scene. I'm going to take a display capture, an existing one, my left display, I think, or right, I don't know which one it is. Wrong one. Let's see. Get rid of that. So I want to do displays, add existing right display. And it's doing a really crappy job. Well, not a crappy job because as you'll see that video is white, which is very much like the background in my office. So it's basically green screening the background. And you can see it's at least showing the, it's showing, yeah, oh, I have it overlaid. So grab this. So now you can see I'm mixing two different sources, right? I'm overlapping these two different images all together. So it's a kind of a terrible example, but that's what I got. And I'll just delete this one, put it back where it was. So anyhow, you can see that there's a really rich kind of different sources you can add together in here, and you can overlay a lot of stuff at once. Back to normal there. So another thing you can do is called transitions. So to show you transitions, I'm going to show you something called studio mode. And over on the right hand right now, when I click studio mode, you see two images. And the image on the right is the same as the image on the left. So it turns out that right now, this framework, OBS Studio, it's broadcasting the thing on the right. So that's what, if you were watching that output, that's what you would be seeing. But let's say I want to queue up, like a DJ, I want to queue up the next thing to show. Well, I select the next thing, okay? So right now, the world is still viewing what's on the right. That's what's being presented to the world. And I'm getting, oh no, that's not the one I want this. No, I do want this after all. So once you get the thing that you want to show, whenever you're ready to show, you click transition. Woohoo, it transitions what you had queued up to be, and this is now what's broadcast on the right. Make sense? Show of nods, positive nods, okay. And just for grins, notice that you have a handful of different transitions. You can do a fade transition. It's kind of not what I expected. Oh, yeah, there's, if you click it. If you click it, that's a fade transition. Or you can say, I want to do a swipe transition. Right? Or you can do a fade to black. Or you can do a luma wipe, which takes away the color. Well, which doesn't make a whole lot of sense on this one, but now I got it all confused. So, so anyhow, I think you get the idea. And all right. And then like on these, you can see you get controls. Like you can say, I want it 300 milliseconds, or no, I want it to take 1300 milliseconds. I want it to be a really slow transition. So you queue up the next one, you hit swipe, and then it's really slow. So isn't that cute? All right. Another thing is you'll notice that we have the logo a lot of times, this DPRG logo. So here, like on this scene, you can see now I have the, we'll go back to normal mode here. Oops. Not that I fumble at all, but. Okay, so if we go to DPRG mode, so now you can see I have the laptop camera with the banner on top. And if I select the banner and drop it down, then it goes below, or I can put it back on top again. And then I can select the banner selected, I can scale it. Well, I can select it. So that's how you can scale it and move it around. So, okay, so you get the idea, right? It's basically video compositing, but it's letting you work with a real-time stream that you can feed out somewhere on broadcast. Another thing that's cool you can do with this is bring in different cameras. So right now, I have two cameras. And to show you what's going on, smoke and mirrors. So here you can see, let's see if I can, okay. So you can see the camera on the left here. I mean, on the one on the right is my laptop camera. And the one on the left-hand side is the iPhone. You also see that there's this bright ring light up there. So you watch, I can turn the ring light on and off. And I can also change its color, different colors, and different intensities too. So right off the bat, what you might notice is that with the laptop camera on the right and the iPhone camera up on top, just watch what happens when you remove the lighting. So the iPhone camera does much better in lower light, right? See the difference? So one thing you can do then is with these tools I'm showing you is you can use external cameras, and even like this iPhone is communicating across Wi-Fi right now. But you can I could pick that camera up and go mobile with it and mix it together with whatever I want to show. Which lets you do another thing, right? So I can say, here is the iPhone camera on the left-hand side. And then you'll see my Club Car Donkey bot down here. So you can see how I can show video of what's going on with a robot. Where'd that go? I can show you what's going on with the robot, even as you can see what the robot is seeing. So whatever you want to mix together, you can think about it ahead of time and compose it, because you can see how difficult it is to do real time. But it gives you the chance to quickly toggle between different things that you want to present. And let's see.
Primarily set up for iPhone, not for Androids?
Yeah, so you're a little soft, sorry, but I think I just heard you ask, was that only set up for iPhone? And at the moment, I'm having iPhone, so that's all I've really worried about. And the tool that I have that I'm using in this particular case is only set up for iPhone. But as you can see, the sources are quite rich. There's quite a nice range of options. And if you had some other arbitrary video capture device, whatever that is, if it's compatible with whatever OBS reads, then you can use it. So whether it's a USB camera or whatever. I like the iPhones because I also have an iPhone 11. Like this one that I'm covering up right now, this is an old iPhone 6, I think, one of my daughters from years back. But the iPhone 11, I mean, there's such awesome cameras. You got people shooting full-length feature movies with these things. So I really like to use the iPhone camera, and it's a remote wireless webcam in that way if your Wi-Fi can keep up. But yeah, you can use any capture device. So I'm pretty sure you could output one way or another. You could output the stream here straight from the robot in a way that the OBS could read it in.
Okay. Cool.
So
did you find that out by experimentation? Just looking up a Raspberry Pi camera and seeing.
Let me turn your volume up. Okay, could you repeat that, Ray?
I wondered if you just experimented and hooked up a Raspberry Pi camera and played with it until it worked, or.
You mean, did I in this particular case?
Yeah.
Oh no, in this particular case, I'm cheating. So what I've actually done is, on my other screen, I have a browser. All right. Oh. So this is the Donkey Car Drive screen. You might recognize it.
Yep. So
what I did was I shoot that over. Like I said, I have 6 monitors going on right now. So I'll show you. That's what I can do. So basically, here, I'm totally wireless. So right now, so here's the screen I'm presenting from, right? And it has a docking station back there. And then I have a presentation just kind of queued up on this screen. But then this screen here in the compose window, I have the part on the left is basically taking the feed from this iPhone camera. And then this bit on the right is a cropped down screen scrape of my third image there. I mean, my third monitor. So I set this particular thing up for this demo where this window is a subset of my right display. So OBS is scraping that monitor and chopping it down and mixing it together. And now you can start to imagine why I say your CPU and network resources can catch up with you. And then the other thing that's going on here is that here's my old workhorse. This is actually the one that's logged into the Google Meet. But I'll show you that in just a minute and why I did it. Okay, any other questions before I go too far down the rabbit hole? All right.
So
Give this
you're
power.
expecting us all to be videographers by the next session.
You know, you can drive yourself nuts.
That's right.
But I mean, it's nice to have the tools, right? When you want to show something and you want to be able to mix it together in a certain way, it's nice to have the tools available, especially when they're free like this, shareware. Okay, so let me see. Oh, other thing I was going to mention was that here on the right-hand side, so you'll see there's a start streaming or start recording. And this is actually what you can use then to do screen scrapes and save movies. So if you have some sequence that you want to share elsewhere, here's a free tool that can capture movies. And it'll capture the audio too if you have it set up to do that. Or streaming, like, it starts to get pretty hairy, so I'm not going to go through all the menus. But like this is what Harold does on his Twitch channel. So he's got this connected to his Twitch account. You can do YouTube, Facebook, Twitter, whatever. And then when he does that, whenever he says start streaming, then it'll show whatever he's got in his compose window, or if he does the studio mode, whatever he has queued up over here. So yeah. So at a high level, that's that. And what you can see is that you can have however many scenes you want, and each scene you can have all kinds of different things stacked up there. And this is what I do basically every week to get that title screen where, like right now, one of the virtual webcams says DPRG 12 September. I have this other computer on the side is queued up with that so that it shows that as one of the cameras and marks our video for us for the recording. So let's see. All right, so before I move on, let me pause. Any questions about what we've seen so far? No head shakes, okay, or the right kind of head shakes. Okay, so we're going to move.
One question.
Go ahead. Yeah.
How long have you been playing with this?
Calendar or hours?
Either.
I started this.
Like soccer with your daughter, right?
I first learned of it last fall when Ron Grant was doing his Wizard of Oz face superimposed over one of his simulators. So Ron, hats off to you. Thank you. You got full credit for dragging me down this rabbit hole. Full credit, Ron. Thank you.
Yeah, to answer Dave's question, though, really, without spending that much time, you can certainly use the tool to do a few things. I admit that, or Carl would admit too, to be really handy with turning on and off chroma key and making adjustments. You kind of need to know where things are. But I've used it for screen capture. I've used it to capture, images off screen movies. That doesn't take long to learn that. And also used it for generally just recording presentation type stuff. And I'm not as savvy as Carl by any means, other than that time I produced the floating head, but that took a lot of effort. And for me to recreate it now would probably take, another hour to figure that out. Although now I've watched Carl's presentation, 45 minutes. Anyway.
Cool.
So how many people are using ring lights? I mean, I'm not using one.
Okay, before I go there, there's one thing. Somebody, if you could at the end remind me to add, okay, so David, directly answer your question. I saw Ron do this. I sat down and tried to get it figured out from the menus, and it blew my mind. So then I found some tutorials, and I was waiting for my car to get some service in the shop. So I sat in the shop for about an hour watching these videos on my phone, and in an hour, I got enough of the gist that I could sit down and spend a few more hours and do what I'm showing you now. So I need to dig out that tutorial because it was pretty decent. Not perfect, but it was more than enough to get started.
So you're saying about a dozen hours you can get well.
Yeah. And then a few more hours to really, because what you have to do is, I mean, if you think about it, right? Here I am trying to present. I'm trying to keep my story straight. And this is exactly why in the real world you have studios. Right? You got teams of people. They've got these pre-canned scenes. They know when you go from this segment to that segment to that segment. It's all set up ahead of time. And you can do that here if you know what and you can see Harold's getting better at that from his Twitch practice, right? Week after week, his overlays are getting cleaner. He's toggling between, he's a little less fumbling. So, but they have tools built in to do that in this. You can actually assign hotkeys to different scenes. So once you figure out those things you want to toggle between all the time, Control 1, Control 3, Control whatever. So it's a matter of, like on the oscilloscope or any of your tools, your coding environment, you figure out the way you like to drive, the shortcuts, and then you don't worry about the rest.
And even on PBS, there's, sometimes there's just dead air. It's a black screen.
Yeah.
So it's not perfect.
Well, think about it. I mean, and that's how many times worse, right? Because it's great that you have people to help you, but now you got 6 people to coordinate and a zillion buttons.
And millions of viewers possibly.
And millions of people watching in real time. So they get good at it, but we don't have to worry so much.
So the bar has been set. There's expectations now about presentation skills and,
Hey, we're all about the learning curve and the growth, right?
There'll be a test next week. So get ready.
You could administer it.
I kind of like the idea that I came up with today, just to slide my face in and out off the screen.
It's so much easier, Ron. And especially because don't let me forget, Ray, I'm going to come back to your ring light question. But when it comes to this little thing here, where you can output to many destinations, oh gods, you can just drive yourself batty. Because imagine all the transcoding that must be going on in here. I mean, I have a pretty fast computer, but I had to crank it up on its CPU speed to be able to do what I'm doing.
Wow.
And it's an i7 with a ton of memory. But okay, I'm going to get into that in just a minute. Let me come back to that. Ray, you asked about the magic ring light.
Yep.
And if you look closely, okay, I first noticed this with when they were having all these TV reports of TikTok, all the TikTokers.
Yeah.
And then I noticed on what was it? American Idol. In the COVID, they had all the American Idol people, they had to broadcast from home. Well, what they did was they got these, literally, they got the setup I'm showing you. They got ring lights, tripods, iPhones, and they mailed them to contestants around the country.
And they had the contestants set up in whatever they had, their living room, outdoor patio, home studio. And they had 3 or 4 of these ring lights and a couple of iPhones on tripods. And then what looked like really expensive audio mics and mixers. And that's how they broadcast American Idol this spring. Amazing. And that's why, I mean, compared to what broadcast quality cameras used to be costing just a couple years ago, we're there. We're right there with what we carry in our pocket for $1,000. Okay, maybe not in low light, but
actually less than 1,000. I was over at Macro Center the other day, and you're right. They have a whole row of setups of stuff for like $35, $70.
Yeah.
So yeah.
Yep.
Well, that doesn't work for me. I'm still in a trial period with my latest phone. I've now armored it well enough, and if it can go for maybe 3 months without me smashing it, like forgetting it's in my pocket and crushing the hell out of it, then I might consider an iPhone. But right now, I'd be on like my 12th iPhone. I would have every generation every year.
Hey, they have insurance plans for that.
They would quickly figure out that I didn't need to be there with their insurance plan.
You would earn your keep. Okay, any other questions from what you've seen so far?
In terms of insurance plan, my daughter had her phone run over by a car, and they wanted us to send it back, which I did, but they replaced it.
Nice.
I've actually had a phone run over by an airplane, if that gives you any
That's cool.
ideas.
Damn.
That's really cool.
I have pictures of it sitting on the wing. And then later, the phone was found. This isn't a commercial airplane. This is a private plane. But anyway.
With the airplane tire track on its back.
Yeah.
Okay.
Tread marks.
All right. So that, where were we? Yeah, we are all mixed up. Okay, so we've talked about all of these things except for how did I get this presentation working? We didn't really talk about that yet. So let's go there, because it's not quite as simple as I led you to believe earlier. So please fasten your seatbelts, because in the real world, what's going on here is this. I have like the computer underneath that ring light is my new workhorse, the X1 Carbon. And then the old one that's logged into Google is actually my old workhorse T530. And I have it set up so that this laptop is sending an NDI stream out to the network, IP, Ethernet. Then this laptop, using this tool, is reading that stream, and then it's feeding it to Google Meet. Okay? And it looks like this, right? It's using this tool called NDI Scan Converter, which I'll mention in a minute. That's running on this laptop. It's an app. So what it's actually doing is scraping this entire screen, and it's doing that because, as I discovered, OBS has problems with my setup because my laptop has a built-in graphics card, 3 screens, I got the docking station, so it's just a little too much for this shareware platform. So I get around it by using this free tool from NDI at NewTek, and that outputs a stream. And what that lets me do is demonstrate, right, this whole panel. I can demonstrate it at full 1080 resolution so you can see the font. And I don't have the problem of recursive picture of a picture and a picture of a picture and a picture, right? Which I would have if I would do this. So if I wanted to, let's see, if I did this. I did the transition, you know, that's what you get. And if I would have just if I would have tried to do this demo and output this screen to Google Meet, it would have been like this and kind of useless. So instead, I set it up like this. And I took advantage of the other tool set that I found. Yeah, okay, so, and then just for grins, before I forget it, how do you select this? How does it look on Hangout? So let me find screen.
So you're saying with one computer, you probably you can't do what you're doing now.
I couldn't have done the exact same demo. I mean, if I wasn't trying to show the OBS control panel, I'd absolutely be fine with one laptop. But because I wanted to show you this without that recursive problem, I needed to get that level of indirection going on. So let's say that you're going to join a Zoom or a meetup. So under the settings, or in this case, under these buttons, you go here, and this is where you choose the audio and the video. And you'll see here, in this case, I have my laptop camera selected, but I can also choose between the output from the OBS studio, and you'll see here that with the plugin I'm using, I can actually have 4 independent outputs at once. So I can select between one of those, or I can choose this video stream. So I would change one of these to like this, and then it would give a preview, but well, actually in that case, there is an output. So, and then I would join, and that's how you can use the output of this OBS as an input to a meetup or a Zoom. So that's.
It looks like it's got kind of a slow frame rate, though.
Well, remember, man, I got a lot going on, right? So
yeah.
I mean, if you think, I mean, and for whatever reason, it's not mapping anything to the graphics card. It's not using the graphics card that much. Yeah, here's the dedicated graphics card. So it's loading down the raw laptop chip instead of the NVIDIA chip. So it's just kind of a mess. So the frame rate, yeah, like I said, you got to be careful of what you're trying to do and temper your expectations.
Hey, Carl, could you put that back up? It looked like the GPU was busy. Did I misinterpret that?
You correctly interpreted it, but it was only doing 7%. Well, maybe that. Well, yeah. So I've had.
No, wait a minute. GPU 3D 30%, 45% of its capacity.
Well, this is a 2 GPU system. So there's the chipset on the motherboard. That's GPU 0. And then GPU 1 is a separate graphics card.
Oh, I see. Okay, missed it. Okay, got it.
Yeah, so the motherboard GPU
Intel part.
But it's not offloading it to the other GPU, because why would anyway, okay, well.
Or if it is, it's so much more efficient that it's got tons of headroom. But then if this one has tons of headroom, then why is it spending any time on this one? So this is where I'm saying it gets a little bit over the top with these shareware tools and production expectations, because there are some controls in here to steer things to one GPU or another, but I can't get it to work quite right. And that's why actually, like I found with my docking station, that's why I had to use this tool, because I can't get OBS to scrape my laptop video when I have the docking station connected. So David, to answer your question, this is where the extra hours went, was because I had ridiculous complication and expectations. But if you have a single, if you're not trying to demo the studio itself, and if you keep your what you're trying to do is simple, then you can step into it in an hour or two.
Probably my 7-year-old i5 would catch on fire, I think.
You can cook your dinner. Get the steak out. Okay. Well, I did warn you to fasten your seatbelts, right? So.
Yep.
Okay. Hey, Carl, question.
Yes.
So just for, you said something that would be kind of, a lot of times I would like to record a YouTube video.
Yeah.
They won't let you record their YouTube videos. I mean, you can't do it. You can go to websites and they'll record it for you and send it to you as a file. But the question I had was, can you record a YouTube video on this and have it as a file on your computer?
So can you pirate it? Yeah, I think technically that's possible, because you would basically do what I've done here. Well, yeah, you do what I did in this case where I'm doing a screen scrape.
Yeah. But where I run into it is, like, if I wanted to, sometimes for a robot performance or something that I want to show for some kids at a school, and I don't have Wi-Fi or anything like that, so I have to have the recording, canned into the laptop to be able to show it.
Yeah.
And so the question was, could you do that? And you're saying it might be possible.
That's what I'm saying. There's a lot of scraping tools out there. But this one happens to be free, and if it's on your display and your audio mixer, you can configure this, I think, so that it'll scrape it and save it.
Are you talking about the NDI or the OSB?
Just OBS. As it turns out, NDI can do it as well, but OBS by itself will do it. And I think there are some ways to download YouTubes in some case, but that gets into developer tools. Yeah.
Yeah, I've done it on occasion without any trouble, regardless of the source so far that I've, I don't, whatever, if it shows up on the screen, it can get it.
Yeah, you can get it. It's just streamed. As long as it's not using a proprietary player, you can often get it straight from the source. But even if it's proprietary, if you're not going to get in trouble with it, you can scrape it. Okay, so next little bit. So we talked about these and why I did this monkey business. I lost some hair on this one, by the way, so I hope you guys appreciate it. I don't have much to lose. Okay, so shake your head. Right, there's a ton of stuff in here. And the way it works is that these NDI tools, by this company called NewTek, these tools over here are free. And I think they're available on Windows, Mac, and Linux. And then these apps for your iPhone. So you've seen camera, right? So actually, capture, let me see, should I show you capture? Let me go off the deep end. Let me see if I can't show you capture. So let's say I want to show you what's going on my iPhone screen itself. All right. So you can see right now that this scene has one source. It's an NDI, my 11 Pro. So I've already got it configured. But now what I have to do is go to my, I'll watch you as I do that, or I'll show you as I do this. So I here we go. NDI. Okay, so I come here and I select the Capture app, and it opens this button. And if I'm on the same network, I sure hope I am, I just click Start Broadcasting. And then I click Start Broadcasting again. You're live. Okay. So now this is live, and it's on whatever Wi-Fi network my iPhone is on. Hopefully it's the same one. It's the right one. We'll find out in a moment. But when that's the case, we go. Yep. There it is. So now you can see as I scroll around on my phone, I can show you what's going on my phone. And you can open apps, and you can
How does playing recordings work? Is it too choppy or blurry?
I've been pleased with it so far, but I think it's like anything else. It depends. If you ask too much of your computer, it's going to struggle and get choppy. And I've definitely made that happen. It's not hard to do. And I've also had the case where, like right now, if you think about it, I've got two different things streaming, right? So I can add to this one an existing, shrink that down. Yeah. So here, right, I can show you on my iPhone all at once.
Mm-hmm.
So isn't that cool? I mean, so now think about it. I have this iPhone and this iPhone. They're both broadcasting like 1080p video streams across Wi-Fi to my Ethernet to the laptop, which is now on this laptop, mixing them together real time. Screen scrape, other laptop, feeding into Google Meet as a presentation, right? So there's a lot of stuff going on. And I can tell you, when I first started dorking around with things like that, I got on the wrong Wi-Fi or something, and I would quickly bring things to his knees, and it just, stuff wouldn't work, and you'd yank your hair out. But when you figure it out and you just take it patiently, step at a time, and now I just broke it. It can be pretty cool. So, okay. So we'll move that over. Okay, so NDI Tools. So I've just shown you, what you've just seen now is iPhone HX Capture. And what that does is screen scrape of your iPhone and send out an NDI stream, which then OBS can read in NDI stream. An HX camera, which we've been watching all along with this iPhone, it takes the camera in and sends out an NDI stream. So it's pretty. So now you can start to imagine, right? Here's this control room with these streams going all the which way, cross-point switches on the right, and now we're able to do it basically with almost free tools on your own personal laptop. So, but there's more to demo. But wait. So these NDI tools, they really deserve their own presentation, and I'd offer that if you'd like, I can dig in deeper than I'm going to go, but I can only go so far today because I couldn't get that much presented. So I'm going to show you two more. I'm going to show you some boring stuff and then some demo stuff. So NDI, you can go to ndi.tv, and I think it's basically a for-profit company that serves the broadcasting industry. You can see they have all this stuff available in their store, SDK, but they do live, post-production, mobile devices, delivery. So they got some pretty hairy stuff. And what I found really useful, so this was another hour or two, David, but they had this technical brief behind this link of the SDK. And in here, they talk about the NDI protocol. So it's a proprietary protocol for shipping video streams, but it's specifically designed to make it easy to merge things together and sync them up and mix them. So it's really designed for this environment. And even though it's proprietary, it's open in the way that there's third-party people that build to it. So I believe I've seen some iPhone, maybe Android, but you can get some apps for your phone which output NDI streams, even if it's an Android. So anyhow, you know, this brief it's like 16 pages. So it's a really high level thing about the protocol, but it gives you a good idea of what's going on and how it works and how you have to be careful when you design your network so that it can handle everything. And then it gives, I mean, just look at this, right? A 1080p is 100 megabits a second. And some of these 4K, you know, 2.5 times that. So it can chew up resources pretty quickly. And imagine trying to do that across Wi-Fi. So, okay, one more practical demo thing. So I'm going to show you, where is it? Studio Monitor. Okay, so here's one of those NDI apps. It's called Studio Monitor. It's on this screen. Come on, little screen. Okay, so what the Studio Monitor does is it lets you view or even record any of the NDI streams that your computer can pick up on the network. So right now, you can see I have a whole bunch presented. So here's my laptop that does the. Okay, don't fail me. It's failing me. Okay, when that happens, it's probably not enough bandwidth. So here's, yeah. So right now, this is just a Studio Monitor window, and it is pulling off the stream for this iPhone camera. But I could just as well pull off the monitor on my T530, which is the Google Meet, so it'll be all recursive, right? Yeah, there it is. So you could just take this and toggle between whatever it is you want to show, and you can see what that source is outputting. Another one they have is called Pattern Generator, so test patterns. So this one, what is? Oh man. So for whatever reason, I can't select it. Oh, it's confused by my screen resolution, I think. So let me do it this way.
For a second there.
Well, I couldn't move the whole window. I can't grab the top control bar of it unless it lets me. Move it. Yeah, it won't let me move it. But the idea is that now you get the idea, right? So I can go over and I can select, like, so right now, my laptop is my X1, right? So it has 4 separate NDI streams that it's broadcasting on my network. So let's select the test pattern. And I can say, no, I want to show this tab, no, this test pattern, or this test pattern. So you get the idea, right? It quickly lets you, when all else is going haywire and you don't know what's going on, you can spit out a known something. And you can try and view it. And as long as the stream is on your network, the same thing as your viewer, you can get an idea of what's going on. Recursive again. Yep. Main output. So, or iPhone. So, let me see. Like normally, if there's audio showing, it would have the VU meter on the side. But like these NDI tools, these are really capable. So that they give you a second way to do screen scraping and recording. Yeah, so those. Okay. So what we've now looked at is you've seen in operation HX camera, capture. You've seen studio monitor. Under the covers, I have scan converter running on this laptop so that we can do the presentation. I've shown you test patterns. Virtual input is like a plugin. So even without OBS Studio, you could use NDI Tools and create a virtual camera for Zoom or Meet. So like I said, there's overlap. You can, this is a virtual input to a web meeting tool, like a virtual webcam. And then these down here, NDI analysis, it's kind of cool. It lets you, it gives you, I think it lets you look at different sources and understand their characteristics and what's going on. I don't really know how to drive it, but I did look at it once, and it helped troubleshoot what was going on to get things hooked up. So there we go. We've covered all kinds of stuff. So comparison, OBS versus NDI. So you've got on OBS, it's open source. You can pull the code from GitHub or the executable. You can start with a laptop. They have a really healthy collection of plugins, and features, and things you can add to the studio. You can do quite a lot of things just with OBS on your laptop, but you're going to be limited by your laptop. NDI, open, but it's proprietary. You can still start a laptop. They have what I find to be really nice documentation and tools. They have third people building on it. You can only do so much with a laptop, but if you want to shell out for professional broadcast hardware, I think they'll either sell it to you or point you to places where they have compatible stuff. So in here, I've got links to everything, except I'll dig out the tutorial and add that link into the tutorial that I followed, like an hour for OBS. NDI, I didn't find any tutorial. They're out there, but I just taught myself. And then I'm going to add in ways so you can get like this particular ring lamp up here. I'll turn it off so it doesn't blow out the camera. So this particular ring lamp, it comes with a pretty nice little tripod. It's really hard to do this. It comes with a nice little tripod and a ring lamp, and you give it USB power, and then you toggle its on off with this control. And then in here I have an adapter, and that adapter is going from a hot shoe to a 1/4-20. And then I have this iPhone clamp. So what I'll do is oh, you couldn't see that because I wasn't broadcasting it. So I'll send links to the ring light, these parts that I just showed you.
Okay, so after you use your ring light, do you see your ring for hours afterwards?
If you're looking straight at it, yeah.
Oh, really?
wouldn't do that.
Yeah. Okay. Do you realize? Do you ever hear of a leg light?
No.
Oh, in whenever they had women broadcasters on, they'd always, they'd set up a light to shine it on their legs for us guys in the audience.
Leg light.
A leg
I'm telling
light,
you.
yep.
You know, audio is the most important part about video.
Yeah.
Except for the lighting.
Would that also be known as a leg lamp? Or is that, I'm thinking of a movie, never mind. I thought of a leg lamp. That was Christmas Story. Never mind. I was somewhere else.
It's all right. We're with
Of course,
you.
I think the leg light is a thing of the past. I don't think you can use leg lights anymore. But they used to.
Okay, so that's what I had to show today. So let me ask, do you guys want to dig deeper at all into NDI another time, or is this plenty for now?
Yeah, I'm interested. It's kind of fascinating what you can do for close to nothing, I guess.
Yeah. Okay.
Yeah, very interesting presentation, Carl. Wow, you've really gone.
We would all look so much more professional in our presentation.
It just amazes me how much and this isn't, I mean, I have decent light from the window behind me, right? But okay,
I think, Carl, you need to go over to Micro Center. I was surprised at how much is being emphasized now. I mean, you go in the front door, it's to the left there. A whole row of stuff.
Yeah.
Yep. Yep. Looks like professional microphones and tripods for everything, ring lights.
We're in that world now, right? Everybody's working from home.
Yeah.
And, they're right on the market.
Yeah.
So,
hey, did anybody ask about that setup in Micro Center? Will they give you a little demo or?
I saw it and I promptly was going somewhere else.
Yeah, me too. I just said, oh yeah, look at that.
In my case, I was there that day to get the resin printer. So yeah, I knew exactly why I was after there. But yeah.
John,
I went there to hunt through bin after bin and not find what I was looking for.
Yeah. Hey, John.
Yes.
I was curious. Okay. So you bought the resin printer. You bought the resin.
Yes.
I guess you bought some IPA alcohol to clean the stuff with.
Actually, I got the washable type somewhere. I have a bottle laying around here. So yeah, I got this. Yeah, I don't know if you can see the label.
Okay, but are those? What else did you need?
That was it. Base of the bottle and the box. I mean,
so
they had
IPA is isopropyl alcohol.
No, it's washable, so you don't really have to use that for this. You can get the type that you have to have the 95% whatever.
So the washable you can just rinse off with water.
Yeah, basically. I mean, I would wear gloves on that. I mean, see it.
What are the trade-offs?
So far, I haven't seen anything different. I mean, I printed this thing, okay, and it feels as hard as the other stuff, and that the resolution is good. I mean, here's the dragon. Unfortunately, I need a ring light right now, as Carl was saying, and that so you can see it because it's black. Yeah.
But I mean,
how long did it take to print?
This one was, I think, about 2 hours, 3 hours.
So
actually, it's actually a little bit faster than the 3D rigger filament print in some ways, which actually surprised me. But the trade-off, well, with this one is the bit is small. Ideally, I would have gone with the what is that? Anyway, the one 3D printer that I had, that company, they had, in theory, went out there for like $1,000. That has more like a 5x5 bed, but right now it's not in stock. This was conveniently here, so I was
$200. You said. Right?
What about strength, John?
Strength? It says tough as I mean, it's pretty tough. I can push
your head off your dragon. No.
Would you say it's kind of like ABS, or would you say it's like PLA?
sort of, it's strong. So I would say it's tough. Or I mean, it doesn't give. You can't really mark it per se. Once the sunlight hits it for a while, the key is you have to have sunlight or the ultra light. In other words, it takes about, initially on the one, well, I don't have that one. Anyway, on the one, I basically printed it upside down so the real detail was on the bed. So when I scrape it off, I put pressure so you hit an indentation a little bit from the scraper. And that's because I said, it's semi-hard at that stage, but it really curl out in the sunlight.
Mm-hmm.
So, when it comes off the bed, it's soft, but by the time you give it a couple hours of light, it gets very tough.
Yeah.
Cool.
Now, hey guys, there's one more thing I was going to mention about the ring light before I forget, and that is that have you ever tried to take photos of documents with your phone? And have you ever noticed how hard it is to get lighting even on the document?
Yeah.
So I tried this the other day, and the ring light works remarkably well. You just get it on a tripod, aim it flat, put your phone up in the middle of the ring light, and you get a nicely evenly lit document.
Cool.
And I'll remind myself Tuesday even, I'll show you a $5 battery operated ring light that you can get for the phone.
Yeah.
I actually have one.
Oh, there's an application for that. I think it's called line following. They ring light your robot.
There you go.
You might.
Yeah. Yeah.
I thought about it when I saw that. I was like,
Yeah.
How big is your ring light? I know you showed it to us, but it was kind of hard for me to gauge.
It is they
come in different sizes.
It's a relatively big one. This is 10 inches outer diameter.
And, okay, 10 inches. And how many LEDs are in it, do you know?
120.
Ooh. Wow.
So I guess with that diameter, I guess you have to think about how far you can be from your subject before you pick up like a specular highlight.
With any diameter, yeah.
Yeah, I guess you have to be way offset if you're far away. So I guess with a typical phone, what do you have to be like within 10 inches of the subject or so to not catch any specular highlight? You know what I mean? If it's a shiny surface, you don't get hot spots unless you're, if you're close enough, you won't have hot spots with that ring, I guess.
I think it depends. Okay, so I worked with a photographer back at PI or TI, and he ran a photography shop on the side full-time as his full-time drafting job. But he was explaining that if you look at different pictures, you can always tell which photographers are careful, because the better photographers will have a soft lighting to fill in all the facial features, but then they'll have one catch light so that when you look at your eye, there's just one single white point.
Speck, yeah.
And if you look at a lot of things today, especially people that are streaming and stuff, you'll often see two white spots on their eye. And that's, they got two bright lights,
right?
Catch lights. And it just looks, if you're a purist on the camera and the video, it looks bad.
Or you could probably see a ring light in there.
Yeah, that's freaky. Ring lights are freaky. Again, that would be probably too far from the ring light.
But then that's where this next thing comes in, right? So that's where, let me go mobile again.
This is the leg light.
So, that's where you have these diffusers, right? Or you see oftentimes the big white umbrellas. And like I have this ridiculously bright Kickstarter light here. That'll cook things. But that diffuser, this thing right here.
Carl, we can't see it.
You can't see it?
No, you're not.
Wait a minute, you're all coming off your,
You're not using your cell phone.
What am I showing?
You're showing your
laptop.
Too many cameras.
Oh my goodness. Okay.
That's been the case for the whole presentation, Carl. We've been just
Where did it go? Now
Nope.
you see it?
No.
No,
Hell. I don't know what I'm presenting. Just a second. I'll fix it.
So that's the cat box view. That's what was shown for most of your presentation, was the overhead view of the cat box.
Yes.
Oh, Ron, you're evil. Okay, is this better?
Yes.
Okay.
I don't see it.
All
Yeah,
right.
I don't see anything.
You're toying with me, right?
Nope.
Must have another window open.
What the hell? Oh, I'm not presenting. That's why.
Yeah. Okay.
If I would present 6 screens, it's just too many. This one. 6. Okay, now there's the cat box view. All right. Yeah.
Oh, there you go.
Okay. Thank you for catching me on that. All right, so this guy right here.
Yeah.
So it's this ridiculous, super bright. Whoa.
Yeah.
Wow, Carl
So
is
the-
into this stuff.
So to break that down, I've got this diffuser, and it's not quite as good as an umbrella, but just on that space right there. So that's super bright light aiming down with this diffuser, and then I was sitting in this chair facing this camera right here, and this diffuser did a nice job of giving soft light without casting a shadow on the back, on the wall.
When I used to take video, one of the things we used a lot was like foam board. Just bright
Foam
white
board, yeah.
and just let it reflect light in the room. It's amazing, or if you have a source of light. Outdoors, it's phenomenal. It'll change your video quality from 40% up to 85%. I mean, just
Yeah.
like putting up a piece of foam
Just to
board.
soften the light.
Yeah. Now the people that are in the video kind of find it that this it is for them it's bright.
I think when they photograph Heidi Klum now, they have to put a stocking over the lens because she's been out in the sun so much.
Yeah.
Well,
So Carl, how much did your ring light cost?
this one, because I chose the largest one I could find at a reasonable price, and it came with a tripod, and it actually came with a phone mount, different than the one I'm using. It was $60.
Okay.
But you can easily find them at $15 and $20 or $30, just depending on, do you want the different number of light levels, colors, white or warm, tripod or no tripod.
yeah,
But this one is
Walmart
$60. I've been pleased.
25 to 50.
Hmm?
Walmart has them from 25 to 50.
Yeah. There's a ton of them out there.
You can get it secondhand from Ken Burns.
They're not as good as the umbrellas, the big white reflective umbrellas, but they're much smaller and they're almost as good for what we do. They're fine. And I mean, the difference is just remarkable, right? Because
Are you guys interested in this for remote meetings?
yeah.
I wonder if my lighting is good enough.
Well, see, no, on you, Jean, your face is relatively dark and you're backlighting, so the shades behind you are overpowering your face. And
I have a lamp here, but I guess I can take a ring light.
and Doug is like dark and brooding, right? His whole side is he's like the Borg man on the side, just waiting to turn around with that little laser light.
Yeah, well, my thing has got mine has got like an ancient webcam that's probably 640 by 480. I don't know. It's really it's an EMT.
But this is the thing, Doug, because if you just gave it more light, you'd probably get it in the better range of the camera.
Yeah.
And then we could see your face.
Mine doesn't look so great.
I mean, your video is better.
Oh yeah.
For everyone here.
Yeah.
So that's
Essentially, Carl, if I fall asleep, as long as I don't fall over, you guys don't know.
That's all right.
I think that's why Harold wears a hat, doesn't he?
Yeah.
Catch the glint.
Yeah. There's, I got a big light obviously coming right here.
Yeah. Yeah.
And it's just burning it out.
Yeah. Yeah, I tried to, I don't know if I could use a ring light. I'd probably be squinting all the time. That's what I got that thing for.
Well, this is the first time I've had it set up above my laptop. I don't know if I'll leave it here or not.
Can you adjust the intensity on it, Carl? So, I mean, you don't have to sit it there and have it blur, burning your eyeballs out while you're.
No. So, like, I don't know how well it'll show. Guys, this is hard to do. Aiming 3 things at once. Okay, so now if I make it dimmer, that's almost off. This is full brightness.
But you got a very bright background behind it with the blind, so it's hard to tell.
It's making, there we go. So if we do, there are the 3 different colors. That's pretty white, warm, and really, really warm. And then if I make it dim or brighter, this one has 11 levels, and then dimmer.
Probably with the correct lighting, if you did it warm, you'd get better ratings on your videos and stuff.
Yeah, depends on what you're trying to do, but yeah.
Yeah.
Or how much you're mixing, right? So I'm mixing this with 3,300 Kelvin LED lights way above. So
yeah.
Carl, your phone is talking to the computer through Wi-Fi.
Yeah.
Is that the one you're talking about just now? The one?
I don't know. Let me see.
The NDI Tools?
Yeah, this is the video right now as I cover it up.
Yeah.
Yeah, the video right now is an iPhone 6, and it's streaming over Wi-Fi to my X1 Carbon using the NDI HX camera app. The X1 Carbon is displaying it using this NDI Studio Monitor app, and then the NDI Scan Converter is screen scraping my laptop display, sending out an NDI stream to my T530, and the T530 is in presentation mode to Google Meet.
So if I use Teams, Microsoft Teams, that's what we do for conference call. Does it get a chance to see this in the camera video? Like
that's what I'm saying. Like I haven't used Teams, but I presume it's like Zoom. So if you have a Zoom like this, right? And you go settings, I think you can see my screen, right?
Let me see.
No, damn it!
It's your.
I don't know what I'm presenting anymore.
Oh, you're not presenting. Oh wait, I don't know.
Nope, not that one. This one.
Might make my.
This one. Okay. So if you have like Zoom, right? You go to the settings.
Yeah.
Video, and then you say what camera device do you want to use, and as long as Teams can see this new tech NDI video, which is the screen scraper off of this main display here, then you should be able to use. You should be able to pull in any old NDI source into Teams. Yeah.
Yeah. I see. Huh.
Yeah. Or you can open up multiple.
Yeah, I'm sure there's some settings I'm looking at.
I guess you can always.
Yeah, I'm gonna stop by Micro Center today. I might pick up a ring light there.
You know, it
Isn't that
comes
cool?
after ring lights, hair and makeup.
Makeup. All right. Okay, so I've been fiddling around for way too long. Is there anything else you guys want to see on this nonsense, or?
No, it's pretty impressive, though. I think it would make all of our presentations, at least my presentation, take a while back.
It'll bring your laptop to its knees pretty quickly.
It probably will.
Okay, well, I'm going to stop the recording then. If I can find the right window.
Very nice, Carl.
Thank you, Ron, and thank you for your inspiration.
Sure.